Thanks for the opportunity to talk about this. Very happy to spread the good word. Nerves has been good to us, so hopefully we can be good to the community. So I'm going to talk about Nerves at SparkMeter, which is the company I work at. And so just kind of the format of what I'm going to talk about is basically in three parts. The first part is kind of who SparkMeter is, what the problem we work on is, why we went with Nerves, and then how we use Nerves. Secondly, there's a promotion for some roles we're hiring for. And then third, there's going to be a Q&A session, which will not be recorded. So the main reason for that is just so I can talk a little more freely, just in case I say something. I don't want our competitor to listen to this and say, oh, you said this part of their engineer said this part of the system is slow. It just removes that worry. And also I think it's a good incentive for people to show up to the meetup. You get to hear all those behind the scenes secrets. So with that, let's get to it. So who is SparkMeter? So we are based in Washington, DC. You can kind of see there's a view. There's the Capitol right there above me. I'm in DC. And then we also have offices in Nairobi, Kenya, and we have employees all over the world. So we design and we sell smart electrical meters. We write electrical grid management software to interact with those meters. And we also have some kind of grid analytics that combines with the rest of those. We serve microgrids, which are typically, dozens or hundreds or thousands, a very small number of generation and consumers tied together, or DU, which is distribution utility customers. So these would be, more of an urban environment and a much larger grid. And we operate primarily in emerging markets. And so that would be Africa, Southeast Asia, places like that. Our website is sparkmeter.io. And I'm very happy to say we've sold more than 150,000 meters. I have no idea how many more, but that's the graphic I pulled, so I'm going with it. And so who am I? My name is Mike Waud. There's a picture of me at Bryce Canyon. And I was originally an electrical engineer at UMass Amherst. And after graduating, I pretty quickly pivoted to back-end software engineering, starting with PHP, going to Python, Ruby, and Elixir. But it's kind of crazy because, even back when I started out, I have a book up here. It's the Joe Armstrong Erlang book. And I read it and I was like, this stuff looks great. I would love to work with it. It didn't make sense at the time, but very happy to kind of come full circle to that and work now in Elixir and Nerves. So at SparkMeter, I work on the embedded and cloud software development of our next generation product offering. And I have a little asterisk here because the work I'm going to talk about here is really the work of many people. I'm the kind of the lucky person who gets to present and talk about it. But a lot of people worked on this project, and certainly Nerves predated me. The choice to pick that out was done before I came along, and the initial board bring up was done by contractors. But pretty much right after that is when I stepped in and started working on the project. So, what does this project do? And this is really how our setup works. You may have seen the slide before, but I'll walk through it if you've seen anything about SparkMeter. So on the left, we have these smart electrical meters, which we design and sell, and they all talk to each other in a wireless mesh network. And they all have RF capabilities, so they can communicate over X distance, let's say. And those all talk eventually to this base station in the center, which a foreshadowing, of course, we'll get to. And that essentially acts as a collector where it collects all these readings, ships it up to the cloud, interacts with the cloud from there. And so the responsibilities of the system are to, collect voltage, current, all these kind of measurements from the devices, energy, just like if your old school meter, if you remember having to look at that and it would tell you how much energy you've used. We also provide data once it's in the cloud to downstream services. So you can do some interesting things like outage detection, which of my customers are without service, how long were they without service. Loss detection is something where we have, within an electrical branch, we have all the consumers would have meters in their houses, but then within that branch, further upstream, we would have something, and we could say, 100% of this was consumed by your customers, or only 50%. So you have 50% loss. There's either something going on in your system, maybe somebody's stealing power, maybe there's some inefficiencies. That's been pretty useful. And then can't actually see the rest of my slide. I have something else written here. Grid health, yes. I don't understand this as much. I don't work on this part, but you can get some interesting things on efficiency of your transformers and that kind of stuff with this data. So that's pretty cool. We can also remotely actuate these meters by telling them to turn on or off, and to say you're only allowed to deliver this much power or this much current. That's really helpful if you have, say, solar panels, so you don't have someone with like a hairdryer using all the electricity in your grid. But really, probably the biggest thing of all this that we do, at least that I work on, is the prepay and post-pay abilities of this. So we actually run billing on these base stations, and post-pay is what you'd be familiar with in the US, where you consume electricity and then you pay for it. But the prepay model is very popular in the markets we serve. So in that case, someone is paying for the electricity first, and then they consume it. And that is a really good model for the operator partners we work with, because they get their kind of capital up front and they can spend that on fuel or capital expenses, whatever, first. And then the customers will consume their balance. So here is the current product, which has worked really well. It's served us really well over its lifetime. It's this industrial PC in the middle. You can see with kind of the Ethernet ports and the USB ports and all that. It's kind of a typical ruggedized industrial PC. On the left here is a picture of the external modem. Not pictured is the antenna, of course. On the right here is the RF gateway. So these both plug into the device, and it works really well, but there are a couple drawbacks. Number one, this industrial PC is pretty expensive. And also, having to plug in these peripherals, anytime we have to debug things with the customer, the first step is always, of course, like, is it plugged in? What are the LEDs doing? All kinds of diagnostics of just checking these peripherals. So with that and a bunch of lessons learned, the decision was made to go all in one and put the modem on a board, put the gateway on the board, and have everything contained in a much more cost-effective package, much more contained, and something really designed for what we need. So you can see this is the kind of final product we launched. I think we officially launched in June of this year, but it's been under development for a while, and it's called Nova. That's the title up there, and it's got you can see the power input over here. It's got some reset buttons, 2 Ethernet ports, Wi-Fi. So we have a Wi-Fi access point where you can log into this locally. It has a connection for the cellular modem's antenna and the connection for the gateway's antenna. An SD card, which we don't use too much in production, but is quite useful for local development. An external SIM. We also have an internal SIM, but typically in the markets we serve, it's cheaper to get an external SIM and plug it in and configure it. And then the unsung heroes of debugging are these LEDs up here. When this thing is misbehaving and you can't get any other interface, this LEDs are really about the only thing I can use to try and figure out what's going on. And I find this pretty funny. After Hello World, I think the next thing people want to do with nerves is they want to build something to water plants. So I don't know all the uses of this device in the field. We have a bunch of them out there. But I got to think someone somewhere has hooked it up to a pump, and that pump is watering something somewhere. So this is maybe my most convoluted nerves project to water some plants. It was really funny also last night. So this is a picture of our web app, and I actually lost power for the first time in a long time last night. So I pulled the outage report basically for my test Nova and meter that I have here. And you can see I lost power for 1.84 hours for whatever, a week. That was almost 1% of downtime. That's just one of the things we offer. And I was curious to see what my power health was like for the full year, year to date. And I've got 99.97% uptime, which is pretty good. So it was neat to see just kind of a practical application of our stuff applied to my own house here. So, okay, that's what we use our system to solve. Why did we choose nerves? I don't think any of this will be probably too new for the folks attending, but nerves really makes a lot of good decisions for us as far as using build root, choosing how to partition our device, having firmware slots, everything in the nerves project, from the platform, the framework, to tooling, A lot of really solid, well thought out decisions. It was really important to us as well to have this be open source and vendor independent. Since it's open source, we can see what's going into this. We can make modifications or suggestions. And with the vendor independence, we're not locked into something. We don't have to worry about this vendor or this product kind of going under. And the easy development and testing on the host machine has been covered by a lot of folks, but can't be understated really. I can't imagine working on a product where this wasn't part of it and having to really only be able to test on the device or bring the device up to confirm that my software worked. Another kind of unsung one is the atomic updates of just having one firmware file and knowing that everything is there. We don't have to worry, was this OS version and this application version shipped independently? With the firmware file, we know exactly what's going out to our devices. Since these update over cellular, small firmware of nerves and build root is also really useful. With the legacy system, there were instances I've heard about where if you're doing a full system update and you're not careful, it can be up to like a gigabyte or something crazy. And with nerves, our firmware is, I think it's 26 megabytes now. And we use Delta firmware updates in Nerves Hub, and that gets us down to about 3 megabytes. So huge improvement for us and a big win there. And lastly, going particularly with OTP and the niceties in Erlang and Elixir, we can remove a lot of things that we might need in other things and using other services. So with Python, you might need Redis for queuing. With Celery, you might need Docker for some things, Modit. All these services we don't need anymore. I will say there is a hidden side to that, which is people know these services, right? If you say these names, people know them. Where if you say a supervisor or a gen server, there's a smaller subset of people who know that. So that is, one of the other sides of the coin of going with this approach. And lastly, we get to use Elixir. I like Elixir, and it's had it's been really well received at SparkMeter. We have chosen it for maybe most of our new projects. I'd have to think about that. There's been a lot of excitement, and there's been desire to rewrite some existing things in Elixir. So it's been a very good decision for us. And so from those, these are the benefits that we actually saw. Within development, we saw that we were able to spend more time on application logic instead of kind of the day-to-day system maintenance kind of things. The same team that implements the firmware features also builds that feature in the cloud, which is really great. So it's not kind of friction between teams and saying, oh, we did it this way, can you do it this way? It's the same person, same team. And all those allow us to ship features faster and more frequently. For sure, we release more updates with this than the previous product because it's that much easier. On the maintenance front, we are able to do some great stuff. All our tests run in CI, of course, we can run them locally. And one of the things I'm really proud of and helps me sleep at night is we actually have a full integration test suite where we bring up the firmware and we bring up the cloud component and we run different scenarios against it. So we test bringing up a whole system, for example, and generating meters in different conditions and making sure that the billing numbers work out. And that is a huge win, really. With Nerves Hub, that is pretty much out of the box, just about lets us manage our fleet and do remote debugging, which also saves us having to build something. And then OTP and the Beam are just so great for robustness and keeping the system running. And that I really enjoy this quote by Robert Verding of any sufficiently complicated program in another language contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang. And he's kind of throwing shade at maybe some other languages there. But you could imagine extending this to Nerves in some ways of any sufficiently complicated blank. I don't know. I wouldn't be prepared to speak to other projects, but certainly compared to a roll your own project, I think it's fair to say it contains some lesser version of Nerves. So, okay, that's why we chose Nerves. That's what we're building. How is this actually implemented? This is, basically just kind of a list of stuff we use in lieu of an architectural diagram. But so on the firmware side, we use SQLite a lot as our data store. That's great just because most people are familiar with SQL. SQLite's a great program, even though it's got a couple quirks. It's able to be embedded within our application. We don't have to start something else up. Having transactions, having foreign keys, all that stuff is super helpful. And if we need to, say, back up the database, you just essentially copy some files very, very easily. We just delete just a few files and we essentially remove all of the system state. It's a great way to run the system. And then VintageNet, I think, is maybe an underappreciated part of the Nerve system. Really, the modem is the only finicky part of that. I had to mess with that a little bit today. Everything else pretty much out of the box, Ethernet, Wi-Fi works great for us. And I think between SQLite and VintageNet, those are probably the two biggest complex parts of the firmware, aside from the application logic, of course. We also use Shoehorn for some application kind of robustness, things that you might expect. We have kind of a custom way of making sure the application stays running. We also use Broadway, not so much for the concurrency, but just to think about how we handle events, how we manage a queue. It's a great standard way that you can just look at something and know what someone's trying to do. We're also big fans of telemetry and Mobius. So big shout out to Matt Ludwig's. So thanks on that, Matt. And this wouldn't be an Elixir project without Phoenix and LiveView. And I'm happy to say for the local access point, we do run Phoenix and LiveView. In the cloud, we use Postgres a lot. We use Kafka a little bit for interfacing with other systems. Again, we use Broadway more for our concurrency. We process these readings and do kind of ETL kind of stuff with Broadway. And instead of Mobius, we use Prometheus, which we've also been very happy with, being able to do alerts quickly in Prometheus or export it and query that from Grafana or other. There's the Prometheus little interface that you can query, has been super useful for our instrumentation. And kind of one of the controversial things we do, which has really worked out, is the way other systems interact with this is if we're trying to do a write, some sort of mutation to the system. We have kind of a HTTP API, which is not surprising. You post with some JSON data and we give you back error codes. But if you're querying with a read, we expose database views of the actual database. So this allows us to always be up, even if we're doing a deploy or something. It allows for a really simple interface where we don't have to stand up a new REST endpoint or GraphQL. Someone can just query with their own pagination or do joins between tables. It's really worked out and well for us and allowed us to develop fast. And so we have a lot of things shared in between these two, which is easy to do because we're using Elixir. It's Elixir in the cloud and on the ground. And we've developed this common event-based library. So that's kind of a combination of a couple things. It's really an abstraction of dealing with the challenges of dealing with a distributed system. So part of it is this custom protocol, which is an alternative to MQTT. I had some frustrations with MQTT, and in a fit of quarantine, boredom or rage, I implemented what I thought was what I needed, and it's worked out pretty well so far. It's basically a pretty simple protocol over TCP. And this idea of a custom event store. So the way we communicate between these two is we sort of write events locally. And then when we have a connection, we send the events and we have conflict-free replication is the goal. We also have some interesting things there with granular subscriptions. For us, that means this meter is on this base station over here, and any updates, we can do the routing with kind of a pub sub approach. If you've seen, I talk about this more in like this sync is what the thing is called. So I gave a talk at ElixirConf last year and this year about that, if you're interested. And then it's not part of this protocol, but we use Avro to encode our actual events, and we've liked that a good bit. And so all of that is powered, of course, by people, and we are looking for some more people. So these are two roles that are very important to me that I would like to promote. So very happy to hear from anybody who's interested, or if you know people who think it'd be a good fit, please do share the postings. The first one is for a Python engineer. This is for that UI I showed earlier with outages. It's both the web UI, it's an API that our customers use. There's a lot going on there. It's pretty cool. And then there's an opening on my team for another Elixir engineer. And what that looks like, kind of, here's a little breakdown. So for us, practically, it's interesting. I think maybe 10% of my time is working with embedded systems or debugging things on more of like an embedded level. Really, the bulk of what we do is what I would consider like traditional backend engineering of kind of moving data around, and you get some requirement from your product folks of doing things a certain way, and you got to figure out how the computers are going to do it. And then maybe another 30% is really more specific to distributed systems of, I have this request in the cloud, but the base station's offline because, whatever, we lost power at the site, the internet's out. How do I make sure that when the system comes back online, it does what I expect it to do? I have data going back and forth. How do I get it to behave in the way that I want it to? So that's a really interesting part of the job. And those are the big components of the position. So I've got some kind of fun pictures then I'll show. So this is the actual packaging that this thing ships in. This is our grid edge management unit is what we're calling it. Pretty cool artwork there. And here is in Kenya. These are some of our operator partners at power utility. They're unboxing. This is some accessories. It looks like some antennas, I think, because they're going to install it at site. And here's my coworker Moses actually installing it. You can see a Nova there in this little cabinet that he's put up there. Here's a little closer view. You can see it there with a few other electronics that do some other unrelated things. Here are some of the guys up on the pole actually installing the antennas. And you can see this dude here. He's got this like belt, which is holding him up there. And he's got these like hooks on his shoes. And, also 240 volt power line up there. So watch out, man. You got a couple things going on up there. And here is where they're actually installing this particular site. This is Kericho, Kenya. It's on a tea plantation. So that's what those plants are. They are tea plants. And this was also pretty neat. So we're in DC. We're very close to the White House. You can actually see it from our office. And one day, the ambassador of Burundi stopped by because we're working with somebody that they're working with. And he wanted to, I guess, see our office and see the project. So I'll let you guess from this picture which one is the tech CEO and which one is the ambassador of Burundi. But I'm pretty sure you can kind of guess who's who there. So that is Nerves and SparkMeter kind of in a nutshell. Thanks for listening to the presentation. And I'm very happy to share. Nerves has been great for us. So, I can't always make a pull request against the Nerve system. So I'm happy to contribute where I can.